In this video, I will show you how to use the properties of special angle pairs like alternate interior angles and linear pairs, etc., to find unknowns. And we will also be using the properties of parallelograms to find unknowns. First, let's run through the special angle pairs real quick. Corresponding angles are angles like x and y, which are both in the same position, like this is lower right and this is lower right, so they are corresponding angles. They will be congruent on parallel lines. Alternate interior angles, they are opposite sides of this line called a transversal. So alternate means they're on opposite sides of the line. Interior means they're between the lines. And if you have parallel lines, these will be congruent. Next, we have alternate exterior angles. Again, alternate means they are on opposite sides of the transversal, but they are exterior because they are not between the lines. And if the lines are parallel, then these will be congruent. Next, we have consecutive interior angles like x and y right here. They are interior because they are between the lines. They're consecutive because they are on the same side of the transversal. In fact, sometimes they are called same side interior angles. Now, this is one of the few angle pairs that are supplementary when the lines are parallel. Not congruent, but supplementary. The last two angle pairs have nothing to do with parallel lines or transversals. These are things that are always true. So a linear pair is when you have two angles side by side that make a straight line, and they are always supplementary. Vertical angles happen when you have an x, and then the angles that are right across from each other are called vertical angles, and they are always congruent. X and y will always be equal. We don't need parallel lines in a transversal for either of these. Notice that as I scrolled across, almost all of these angle pairs were congruent. All right, congruent, 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 congruent. There are only two of these that are supplementary. So it might be easier to focus on the two that are supplementary, memorize those, and then you'll know that all of the other pairs are congruent. So the two supplementary ones are linear pair, all right, which is obviously supplementary because they make a straight line, 180 degrees. And then consecutive interior angles, or same side interior angles. These are also supplementary on parallel lines. Everything else is congruent. Okay, I think that's enough information for us to get started. Okay, so problem number 1. What kind of angle pair is this? Hopefully you can see that these are alternate exterior angles. And since the lines are parallel, these will be congruent. So that allows me to say that 14x plus 4 should equal 13x plus 11. If I subtract 13x from both sides, I get x plus 4 equals 11. And then I would subtract 4 from both sides, and I get x is equal to 7. All right, number 2. What kind of angle pair is this? This is a linear pair. Notice how they make a straight line. And a linear pair is always supplementary. So these have to add up to 180. So I should go 9x minus 8 plus 12x minus 1 is equal to 180. All right, they are supplementary. Now I've got these like terms. 9x and 12x are like terms. So that's going to be 21x. And then negative 8 and negative 1 make negative 9 equals 180. So I need to add 9 to both sides as I try to get x by itself. So now I have 21x is equal to 189. Finally, I will divide both sides by 21 and calculator. So 189 divided by 21. That's 9. All right, on to problem number 3. What kind of angle pair is this? Well, these are consecutive interior angles, or same side interior angles. And since the lines are parallel, these should be supplementary. So again, I'm going to say 15x plus 5 plus 70 should equal 180. All right, supplementary. So my like terms are the 5 and the 70. So I will combine those, and then I have 15x plus 75 is equal to 180. We will subtract the 75 from both sides. So that's going to leave us with 15x is equal to 105. And finally, I will divide both sides by 15. All right, so let's check and see what that is. So 105 divided by 15. That is 7. All right, there's number 3. Okay, problem number 4. These are alternate interior angles. And since the lines are parallel, these should be congruent. They should equal each other. So I can just go 14x minus 2 should equal 110. So I will add 2 to both sides, and I get 14x is equal to 112. And finally, I divide both sides by 14. That's 8. Okay, number 5. These are corresponding angles. That's what you call this angle pair. And when the lines are parallel, these should be congruent. So I can just say that 7x plus 7 should equal 6x plus 16. Whenever I see a variable on both sides, I subtract one of them so I can get them together. So that is going to give me x plus 7 is equal to 16. Then we will subtract 7 from both sides, and that will give me x is equal to 9. All right, number 6. Well, these are vertical angles, and it actually doesn't matter whether these lines are parallel or not. Vertical angles are always congruent. So these should be equal to each other. So I can just go 17x minus 3 will equal 15x plus 5. Variable on both sides, I'm going to subtract one of them. So that's going to leave me with 2x minus 3 is equal to 5. And then we should add 3 to both sides, which gives us 2x equals 8. And when we divide both sides by 2, we get x equals 4. All right. So now we will switch gears a little bit and talk about parallelograms. When inside of a parallelogram, we know that opposite angles, like this angle and this angle, will be congruent. Opposite angles will be congruent. However, consecutive angles, like R and S, will be supplementary. And that's what we're doing right here. Okay, these will be supplementary, so they have to add up to 180. So I should go 11x minus 4 plus 4x plus 19 should equal 180. The 11x and the 4x are like terms. That makes 15x. The negative 4 and the 19 are also like terms. So I'll put them together and I get 15. And that is equal to 180. So of course I will now subtract 15 from both sides. So that will give me 15x is equal to 165. And then I have to divide both sides by 15. Okay, opposite sides of a parallelogram are congruent. So these opposite sides will be congruent. So that means that 4x minus 3 should equal 7 plus 2x. I see the variables on opposite sides. I'm going to subtract one of them to get them together. So that's going to leave me with 2x minus 3 is equal to 7. And then I will add 3 to both sides, and I will get 2x is equal to 10. And then I divide both sides by 2, and I get x equals 5. All right. These are opposite angles, and opposite angles of a parallelogram are congruent. So that means that 6x minus 6 equals 16 plus 4x. So I see variables on both sides, so I need to go ahead and subtract the 4x from both sides. And that's going to leave me with 2x minus 6 is equal to 16. Then I will add 6 to both sides. So that'll give me 2x is equal to 22. And when I divide both sides by 2, I find that x is equal to 11. All right, number 10. These are opposite angles, and in a parallelogram they are congruent, which means that 12x plus 14 should equal 110. So I'm just going to subtract 14 from both sides, and I have 12x is equal to 96. Then I'm going to divide both sides by 12. And we get x equals 8. All right. So now that we've put the diagonals inside the parallelogram, we can use some additional properties. So let's see, ZF is 15. Let's color coordinate this a little bit. Okay, so ZF is 15. So here is ZF right here. Okay, that is ZF. Now, DF is x plus 18. All right, so DF is here. So, the property of a parallelogram that we're about to use is the fact that the diagonals bisect each other. That means that they cut each other exactly in half. So, what we're looking at is, since we have two halves, they should be equal. So, we have a half is equal to a half. All right, that's the framework that we're thinking in the back of our minds. Okay, so a half is equal to a half. So that means that the green should equal the red. So in other words, x plus 18 should equal 15. If I subtract 18 from both sides, of course, I get -3. So x is equal to -3. All right, looking at number 12, we have DQ. And DQ is right here. But then we have DB. And DB goes from here all the way to here. So on the previous problem, we had two halves. But this time we have a half and a whole. So whenever you have a half and a whole, what you should be thinking is 2 halves equals a whole. All right, makes perfect sense. 2 halves should equal a whole. So just remember that the red is the half and the green is the whole. So if I do 2 halves equals a whole, that means I need to do 2 times the red, which is the x plus 8, and that should equal the whole, which is the green, which is 3x minus 4. So the way you solve a problem like this is by doing the distributive property, and you get 2x plus 16 is equal to 3x minus 4. Then we need to subtract these. Now I like to keep the x positive if I can, so instead of subtracting 3x, I'm going to choose to subtract 2x from both sides. So that will leave me with 16 is equal to x minus 4. And finally, we can add 4 to both sides. And that leaves us with x is equal to 20. So that's what you do when you have a half and a whole. So we need to find the measure of the question mark here. So let's see. Let's find everything we can, actually. So I'm noticing that in this triangle, on the right-hand side, we have 2 out of 3 angles given. So whenever we have that, we know that we should be able to find the missing side, the missing angle, because all 3 angles have to add up to 180. So I should be able to subtract from 180. So if I do 180 minus 44 and 62. So minus 44 minus 62. That leaves 74 degrees. So this angle right here should be 74 degrees. One of the properties that we know is that opposite angles in a parallelogram should be congruent. That's angle W and angle U. Those are opposite angles. So they should be congruent. All right, so I'm going to have a 62 right here. Okay, now what else can I do? Let's use alternate interior angles. All right, if we can. Here's how we use alternate interior angles. Draw an N or a Z. All right, can you see the Z? And it doesn't matter. Sometimes the Z will be backwards and it still works. But here's my Z. The corners of the Z are alternate interior angles. And since this is a parallelogram, the alternate interior angles should be congruent. So that means if this angle in one corner is 44, that means the other corner will also be 44. So that tells me that that angle is going to be 44 right there. Let's do that again. To find the question mark, I could subtract from 180. I could take the 62 and the 44 and subtract from 180. But it would be easier to use alternate interior angles again. All right, so this time I'm going to make an N shape. All right, okay, it's really a backwards N, but you still get the idea. Or you could think of it as a sideways Z. All right, but the point is, if you draw an N or a Z, if you draw this zigzag, the corners are alternate interior angles, and they should be congruent since the sides are parallel. So if this corner has a 74, that means that this corner is also 74 degrees. And that's actually the one we were looking for. So the answer is 74. Okay, this one is going to be extra easy because I see a right angle here, and that right angle automatically means that all of the angles have to be right angles because this is a parallelogram. So that means we have a right angle over here, we have a right angle over here, and a right angle over here. So of course that means that these two have to add up to 90. So if this is 47, then this angle must be 43 because 90 minus 47. And that's it. So the answer to number 14 is 43. Just not much to it. And that's it. That is how you use special angle pairs and properties of parallelograms to find unknowns.